Right. So can anyone tell me what's a piezoelectric crystal? It's a crystal that can vibrate to generate AC current. Okay. Any other answer? What's a piezoelectric crystal?
It can receive potential difference like expander contract.
Right. So that's one of the reverse as well. Correct. So piezoelectric crystal is this crystal that can generate potential difference due to deformation and can generate and due to a potential difference, it can undergo what? Deformation. Okay, so if you provide a potential difference, it can deform. And if you deform it, what does it do? Provide a potential difference, right? So that's a piezoelectric crystal. It has nothing to do with ultrasonography only. It's just a crystal that's used in many different places. But turns out ultrasonography, that we use it somewhere. Where in the ultrasonography process is the crystal involved? The transducer. So the transducer is a device that's used to produce the vibrations, right? What kind of frequency do you think the transducer needs to run at to produce these waves? Yeah, 20,000 plus. Okay, it's actually something like more tuned with 40,000, 50,000. On the syllabus it at night, but I'm just share correctly. Higher the frequency, what the wavelength? Shorter the wavelength, right? And turns out the smaller the wavelength, the more precise your readings. So if you're trying to take very precise readings, right, you need what wavelength to work with, very small wavelength. So it like edXLR question asks, that if you want to improve the precision of your recordings using ultrasonography, right, what frequency is needed? High frequency. High frequency waves low, so they can bounce off smaller structures more easily. And if you have a very big wave, right, sometimes it jumps over the structure. And it's like refinement precision bar. Okay, so that's the transducer. Achieved or needed? Achieved only millions. No particular purpose of it, but there's something called an ultrasound cleaner. They use ultrasound to clean metals. So they go up to 100,000, 200,000. The higher the frequency, the better it cleans it. Okay. The 3D ultrasonography. 3D one is a little different. So the 3D ones are very realistic. You can actually see better, right? It's not high frequency. So the 3D one, typically, if you want to create a 3D image, right, what you need information from the front, the back, and the sides, right? So the 3D ultrasound system, right, I think it sends waves from multiple directions. It's still a transducer, but it's a very big transducer, and it produces, I think, like multi-dimensional waves. We do have 3D scan in our syllabus, but we do that in CT scan. So we'll be doing CT scan very soon. Right, so that's how it's generated. So can you tell me briefly the process of ultrasonography? Like, what does it do? It helps us. Right, a very good answer. It helps us identify the location of different structures within the body, right? And also that allows us to find the different sizes of the structures inside our body. How is it achieved? So it uses echolocation. That's the idea. So what it does is it sends the sound inside the body, and the sound goes through your body. But the sound reflects. Where does the sound reflect from inside your body? Barriers or boundaries. Okay, so any change in medium will cause a reflection to take place. So as the sound is going through the body, you'll find like muscle, tissue, bone, different ligaments, right? Fat, just bounce back for a bit. And as it bounces and comes back, this is what we're going to do today, math correct. How much returns from a reflection depends on the what? Like how much amount of your wave reflects and comes back depends on what? The difference in density of the medium. So if you have a medium that are too similar in density, will the reflection be very high or very low? Very low. So muscle to muscle, right? Barely কিছু দেখা যাবে. But muscle to bone, very good. Bone to tissue, very good, right? Liquid to muscle, very good. That's why ultrasonography is very good in finding differential structures, structures that are different. So let's say you want to do ultrasonography of your kidney, right? It's going to be very easy to do an ultrasonography because your kidney, right, is surrounded with cells and tissues that are very different from what the kidney is made up of. So when the sound comes in, finds different structures in the kidney and it bounces off very easily. Similarly, the liver is a very different dense material inside your body, right? But around it, it's like the soft tissue and muscle and fat and everything, right? ওগুলা থেকে যখন liver enter করে, that's a very big change in density. So liver খুব easily দেখা যায়. So these structures are very easily seen, but it has a drawback, ultrasonography. If you have, let's say, an ailment within the muscle, like a muscle tear, এটা ultrasonography দেখা যাবে না. কেন? Because a muscle tear is still a muscle, right? So the ultrasound just passes through it. So if you have, let's say, nerve disease, nerves যেমন ultrasound show হয় না. So we have much more advanced techniques out there like MRI. But we'll learn that as well. MRI, sorry, MRI শিখবো না. PET scan. PET scan is much more advanced. Right, so that's how it's done now. What happens is you send waves. Do you send like a series of waves or do you send a pulse? A pulse, right? And why do we do that? Overlap. Pulse something like that. Right. So now main reason why we use pulses is so that the send signal and the receive signal can be distinguished. কারণ তুমি যদি continuously send করে যাচ্ছ আর continuously back করতেছে, you wouldn't know which one came back when. Because for us খুব বড় একটা information when they come back. Because by knowing when they come back, what can you predict? The distance, right? তার জন্য it's very important to know যে I send this wave, did this wave come back or not? কারণ আমি ধর 10টা wave send করলাম. Let's say throw 10 waves there, right? And 10 waves come back to me, but they're all the same wave. How would I know which one is which one? They're all the same, right? So we send one. It goes, it comes back. I know for sure that's the one that came back. And then I send the next one. So we need to give it a gap before we send the signals, right? ওটাকে কি বলা হয় the gap? Pulse interval. Our pulses size-টাও matter করে. ওইটা যদি বেশি বড় হয়ে যায়, it might be যে sound send করে যাচ্ছে বা sound already চলে আসছে. What is that called? Pulse duration, right? Okay, so these are things out there. Okay. Oh, so good question. So when you're doing ultrasonography, right, you're actually doing over a region. So if you just do send receive, right, that's like a very narrow band that information you got. So what they'll do during ultrasonography, they'll move around like that because they want to capture more information out there. So that's why you're continuously sending it like that. Okay. Right, so this is the process the working. So working principle of ultrasonography. I think I told you last class that এটা হচ্ছে 8 marks একটা question থাকে তোমাদের. So this is the one. Okay, we'll see the answer right now. The loop. Oh, it's called the coupling medium. I'll come to that. ওটা math করে বুঝতে হবে. Why do we need that? The gel, right? Okay. Yeah. Yes, I think just miss course. Ashar Abdi discuss course. Can anyone tell me why don't we use infrasound? The infrasound 20 hertz and niche, right? I could basically create infrasound with my hands. Yes, so the wavelength will be so large it bounces over your organs. So imagine this is your spleen. There's an organ, and the wavelength is like that big, right? So the wave is like this. So it'll just basically skip the spleen and go away. It wouldn't fall in its path. But if my wave is like really small like that, wouldn't it bounce off the spleen very well, right? So that's a spleen. We want to find a kidney stone. By the way, stone it's a problem. But let's say it's like that size, right? Now you have a wave that's like this, like the airport. There's chances that it'll bounce over it. How do I ensure my wave definitely hits it? A much high frequency definitely will come and collide with my structure. So discuss not only we use ultrasound, we use higher frequency ultrasound like 50 hertz, 100 hertz, so that we can reduce the wavelength. Okay, that's the reason. Okay, let's just quickly go through it. After class, in your exam you get 8 marks just from today's class. Okay, so I'm going to 8 mark math and potentially 15 marks. Let's say they give you the description and they give you the math. Just 15 marks of your exam. That's 15% of your exam. That's a lot from one single class. Okay, so pay attention. Before that, let's just go through this. Ultrasound is sent into the body in the form of pulses, and these pulses reflect off boundary in the body. The greater the difference in density, the higher the reflection. মানে তোমার যদি গ্যাপটা বেশি হয় তাহলে ডিফারেন্সটা বেশি হয় তাহলে রিফ্লেকশন বেটার হবে. The time needed for the ultrasound to return and their intensity can be used to determine the type of material and also their location. Because not only the doctors want to know how far things are, they also want to know what is it. Because there are two information that I need. I'm doing ultrasonography, right? আমার জানা দরকার হচ্ছে where the thing is and what that thing is. So where the thing is the time telling me how far it is. What the object is attained from what information? The return intensity. So if the return intensity is very high, it must be a solid object. If the return intensity is very low, it must be a muscle or a tissue boundary. So doctorদের জন্য হচ্ছে those who are like used to doing this, ওরা চার্ট দেখে বুঝে ফেলে যে height দেখে যে কোনটা muscle কোনটা bone, because it's very similar for everyone. Okay. তারপর আরেকটা কোয়েশ্চেন হচ্ছে explain the use of coupling medium and transducer. এটা আমি একটু পরে explain করবো because we need the math to do this. And আরেকটা হচ্ছে to ensure there is no overlapping of information, we send vibrations in the form of pulses in intervals. This allows the signal to travel, reflect, and return before the next pulse is generated. This is done to allow the crystal to perform one operation at a time. The crystal can to send or receive করতে পারে, send and receive করতে পারে না. Because when it's in the receiving mode, তাহলে হচ্ছে what does it generate? A voltage. When it's in the sending mode, it receives voltage and generates what? Vibration, right? So if you can't do both of them together. Right, so questions থাকলে বলো before I start the math today. As I told you, you get a math that's 3 steps থাকে. It can be potentially 8 marks, like a 5 mark and a 3 mark question. Okay, so তার আগে কোনো question থাকলে আমাকে বলতে পারো. Oh, it's very fast. The interval we're talking about sounds like it's like you couldn't actually notice it. You won't notice it. That's a good question, actually. So the ultrasonographer, the person who's going to do it, right? Depending on where you're doing your ultrasonography, they will set the setting. So I'll give you an example. So they'll ask you to do an abdomen ultrasonography because the abdomen is very big in size. The intervals need to be longer. But then they'll ask you to do an ultrasonography of, let's say, something that's closer to the surface. Could be, let's say, lungeর হচ্ছে ultrasonography, kidney. So kidney is much closer to your surface, right? You're not doing the full abdomen. তখন হচ্ছে they'll reduce the interval because you don't need all that information to come back. You just need the surface information. So based on where you're doing the ultrasonography, they'll actually adjust it, the time frame. And nowadays, the modern machines, as I told you, the people who do this, they don't even know what's happening. They just set it. Like, there's an option like abdomen. Yeah, they're all fixed out there and it does it for you. Okay. Right. So currently, the challenge in ultrasonography is not like if you want to become an ultrasonologist, it's not the working of the device, it's the reading of the information. So অনেক misread হয় যে let's say you do an ultrasonography and there is something that you see. One doctor will say nothing, the other doctor will say life-threatening tumor. And it happens because it's at the end of the day, outcome হচ্ছে subjective. It's a person's opinion that is the thing. So currently, they are working on a system that uses AI, and AI right now success rate is 98%. A person's success rate is 60%. So in future, it's like you can do self. You just go somewhere, put like a $10 inside. They'll give you the machine, do like an ultrasound. They'll tell you what's wrong. It's like a vending machine. It could be like that because that's how it's supposed to be. The computer will decide what's going on. All right, let's start the math. Right, so বুঝছো basic idea টা আছে? They won't say it. So they'll have to send the information to like a doctor. The doctor will verify that, and then finally the doctor has to sign it off, and then you get the report. Because normally when they're doing it, they're just taking pictures. Then somebody else has to see the picture and come up with what's going on. Okay, let's start. Oh, by the way, just a quick reminder. Do you remember this one? Yeah, but what's this scan called? B scan is called brightness scan. So এটা যেটা করে, they take the reflection information and convert that to what on the screen? Light intensity. So the places where the reflection is very strong appears what on your screen? Very bright. And the places that are like, shadowy are things that are very similar in size, okay? So like the human skull, the fetus skull is the one that forms the first. ওইটার স্ট্রাকচারটা বোঝা খুব ইজি হয়ে যায়, okay? Like, other organs পরে দেখা যায়, and I think the one she mentioned, the 4D scan, like একটা 3D scan, that's a modern version. It uses multiple tools and it can actually show you a 3D version of the body inside. That's how the syllabus is like very advanced. Okay, let's get to the math right now. So how do we do our calculation? Or more importantly, what calculation? When a key calculator very okay, so let's see that. So what we are trying to do right now is find out, listen carefully, the intensity that reflects and comes back from different boundaries. So let's say you send a wave with intensity 100, and that wave is traveling through the body, and it goes from a muscle to tissue. Isn't there a difference in boundary? Kichu reflection back করবে না? How much reflection comes back? ওটা math করে বের করতে হবে. Because that information, how much comes back, tells you that it's a muscle and a tissue boundary. So different boundaries have different reflective coefficient bola hoy, like fractions. That's what we're going to see right now, how to find those, okay? So before we start that, we need to learn a quantity. It's called the specific acoustic impedance. What is specific acoustic impedance? So it's a property of sound. Ultrasonography te jeto sound use kora hocche, it's a property of sound. And let me explain what this is. It hocche given by the symbol Z, and it is the product of the density of the medium. It's a definition you get in your exam. Is the product of the density of the medium into the speed of sound in that medium. This is the formula, okay? So it's called specific acoustic impedance. Specific acoustic impedance. Does anyone know what is impedance, the meaning of impedance? So just a heads up there, okay? আমাদের UK syllabus-এর মধ্যে we are taught a quantity wrong. ওটা হচ্ছে electricity-তে. So electricity-তে there's something called the Ohm's law. And Ohm's law মধ্যে V equals to IR, right? R থেকে কি বলি আমরা? Resistance, right? Resistance কেউ use করে না. That's not the right term. It's called impedance. Impedance and reluctance. There are two versions out there. Impedance is like resistance. So once you go to university and you start electricity, first thing you'll notice that they don't call it resistance. They call it impedance. A specific acoustic impedance ki tahole? How much barrier or resistance, what experiences as it travels through? Sound. So different medium will provide different what? Barrier and resistance to your sound. That is basically this measurement, okay? So rho here is the density of the medium. So density ratio like key ratio of impedance, right? Density of medium. And V is the speed of sound in that medium. Sound in medium. So this is the first thing you need to know. Z, which is specific acoustic impedance. Right. Now, what do we do with this information? So just screen it. There, again. So I'll give you a formula. Formula to তোমাদের হচ্ছে দিয়ে দেয়, I think, but তাও দেখাই. So listen carefully. We need to find something called the reflection coefficient, মানে fraction. Reflection coefficient is given by the symbol alpha, and alpha equals to the reflected ray divided by the incident ray. Let me explain, okay? So intensity of reflection divided by this is intensity of what? Incident wave মানে কি এটা? So এটা হচ্ছে, I was saying earlier, how much is reflected, that is called alpha. So if your alpha is 0.9, right, what does it mean? So it means alpha 0.9 যদি হয়, or 90%, it means of all the wave that you have sent, how much comes back? 90%, okay? And যদি কোনো alpha একটা value জানো তোমরা, like a doctor will be able to say what the boundary is. So bone to muscle alpha is like 70%. So any doctor who sees the ratio of intensity as 70%, they know right away that what's the structure that the sound came from, a bone. So আমাদের যেটা করতে হবে, we need to find a different alpha for different medium out there. And ওটা করতে গিয়ে I can teach you like কেন হচ্ছে some boundaries are good and not, right? So alpha বের করার formula আছে একটা. Alpha equals to এই যে incident reflected ratio is equal to, look at this carefully, Z use করবো আমরা. Z1 minus Z2 whole square divided by Z1 plus Z2 whole square. A acoustic impedance use করে you can find alpha. So how do you find alpha? So let's say there is a wave traveling from here, যেখানে Z হচ্ছে 1, to another medium, যেখানে Z হচ্ছে 2. Wouldn't some wave like reflect off this boundary? So কিছু তো reflect করে যাবে, but সব কি reflect করে? না তো, right? So some of it will what as well? Just go straight, like refract. Okay, so আমাদের যেটা করতে হবে, একটু carefully notice করে জিনিসটা. This one is my what intensity incident. This is my what intensity reflected. The problem is, or our recent papers gulote, they also want you to find this one. This is the what. This is the intensity of the passing through. I mean, R likhlam na, but this is the one that is refracted, right? So can you tell me, if I know this and I know that, how do I find that? Subtract. Okay, so I minus IR. So এই ম্যাথটা জিজ্ঞেস করবে ওরা, যে ওরা জিজ্ঞেস করবে how much of the wave actually passed through. So তোমরা ম্যাথ করবে এইভাবেই করে, ধরো তোমার রেশিও আসলো 0.7, that means 70% went out. How much went in? 30%. That number is important, by the way. We'll have to use it later on. So কেমনে বের করবা কোন ফ্র্যাকশন বের হচ্ছে বা চলে যাচ্ছে, এই যে এটা ইউজ করে. Alpha is this by this, and that is Z1 minus Z2 divided by Z1 plus Z2 whole square. And eta use করে what you can find out, how much goes in and how much stays out. Okay, so I'll give you some numbers to work with just to get a feel of this equation. Eta দিয়ে হচ্ছে বললাম না, the 6-7 mark question আসে, এখান থেকেই start হয়. So we'll get to that in a minute. So before I start the math, do you have any questions? That's it. Just formula জানতে হবে, in fact formula দিয়েও দেয়, the Z formula. So তোমাদের just বুঝতে হবে what does it do. So the alpha is basically reflection coefficient. It tells you what fraction gets reflected of the wave that you sent in. Why is this information important? The amount that reflects tells us, reveals to us the type of material inside the body. Okay, because intensity or depend on it. Okay, so let's see a sample question that তোমাদের একটা idea হবে. No, just B. So when you go for ultrasonography, right, the ones that typically happen, that's actually just B scan, brightness scan. A scan is normally needed for high precision measurements. Nowadays, no one uses ultrasound for that. They'll ask you to do a CT scan. A CT scan is way more precise. There's nothing next to it. Ultrasonography is a quick solution. Also, there's the reason why they prefer ultrasound first, CT scan later. Do you know why? দেখবা যে কোনো প্রবলেম হয় তোমার, ফার্স্ট এ বলবে just do an ultrasound. Close. Yeah, safety. Ultrasound you can do 100 times in a day, কিছু হবে না. CT scan has a limit. CT scan uses X-rays, and X-rays are ionizing. So CT scan কিন্তু একটা barrier আছে. তো বাংলাদেশে they don't follow the rules. It's actually 6 months হচ্ছে maximum 2 times. In a given 6-month period, you shouldn't do more than 2 times. I've heard people do it 3-4 times in a week. It's actually very harmful. CT scan, and then the thing is, it's just how the medical industry is in our country. Because to me, একটা CT scan নিয়ে গেলে কারোর কাছে, they'll be like, I don't know what this is. Art করেন, আমার এখানে করেন, and they'll do it here, and that's how it works. But the thing is, it's actually very harmful for you. X-rays and CT scan, not more than twice every 6 months. Okay. In fact, CT scan I don't know if you know, they'll put a dye inside your blood. CT scan করার সময় they'll inject like this liquid into your blood so that the liquid passes through your body. It's called a contrast medium. We'll learn about it. ওটাও harmful. ওটা এত often দেওয়া is not good. It's something that's basically a dye. It's a metal that's put into your blood so that CT scan your blood veins show up. Casually করে মানুষজন এখানে. So just keep that information for yourself. Right. Anyways, let's try this question here. Air has an acoustic impedance Z of that much, and skin has an acoustic impedance of that much. Okay, what we are trying to find out right now is, let's say you have this boundary here between air, by air, and inside you have the skin. Okay, so আমাকে যেটা বের করে বলবা তোমরা এখন math করে is what fraction of the wave that you're sending in reflects. So let's call it I incident. তোমাদেরকে বের করতে হবে IR, basically alpha বের করতে হবে, আর কিছু না. That's what the information is, right? What's the Z for air? 400. Unit খুব easy, কিন্তু ইউনিটটা দেখে মনে হচ্ছে অনেক কমপ্লিকেটেড. ইউনিটটা ইজ দি র ইউনিট মানে কি ডেন্সিটি ইউনিট ইনটু স্পিডের ইউনিট. ডেন্সিটি ইউনিট কি কেজি মিটার পার সেকেন্ড কিউব, কেজি per meter cube, sorry, and velocity is what? Meter per second. ওই দুটো মাল্টিপ্লাই করলে এটা পাই আমরা. So the unit is just that. So 400 kg meters, and the Z for skin is this. So let's see what the Z is for a skin. Z for skin is 1.7 into 10 to the power 6. Obviously, the skin produces more impedance to the sound, right? Find me alpha. So find alpha, which is what? Fraction that reflects. Zero point nine nine nine. আচ্ছা দেখি আর কারো কোনো অ্যান্সার আসে নাকি? Yes, that's the answer. Okay, so কেমনে এটা করতে হলো? দেখো, alpha equals to Z1. Take anything, 400 or oita, doesn't really matter, because at the end of the day কি হয়ে যাবে এটা? Squared, right? Divided by 400 plus 1.7 into 10 to the power 6, and squared and squared. And এটা করার পরে হচ্ছে you'll find that your alpha is কত? 0.999, right? Can anyone tell me what does this mean? How much of the wave that you sent in, right, came back? Exactly. So the amount that reflected is 99.9% of the wave that you sent in. Is that a good thing or a bad thing? It's a horrible thing, you know. It's basically the sound never entered your body. The ultrasound kora to possible na. Do you get my point? So this is where we solve this problem. So I'm only key. It's a very common issue. You want to do ultrasonography, you take the transducer, you place it on a person's body, right? And you send the beam in. Screen kichu ashe na. Keno? Because what's there between the transducer and the body? Air. And all the sound is actually getting reflected from where? The air, the surface. Nothing enters the body. Tar jonno, what do we do? So that's the reason why when you go for an ultrasonography, you'll find that they will provide something on your body. Ora ki kore? Korar agde body upor ekta gel provide kore erokom. And that gel is like a very fluid material like that. And you place your transducer on top of that gel. So basically the transducer is where? Inside the gel like that. And the gel has the exact same Z value as the human what? Skin. So you're basically extending the skin into the transducer so that nothing is wasted outside. বুঝছো জিনিসটা? So আমার যদি এটা না থাকতো, এখানে সাউন্ডটা ফার্স্টে কোথায় যেত? এয়ারে. বাট এখানে এটা দেওয়ার জন্য যেটা হচ্ছে, সাউন্ডটা এয়ারের সাথে ইন্টারঅ্যাক্টই করে না, ইট গোজ ইনটু দ্যাট। আর এই বাউন্ডারিতে কোনো রিফ্লেকশন হয় না, বিকজ হোয়াট ইজ দ্য ভ্যালু ফর জেড ফর বোথ অফ দেম? সেম। তোমরা যদি হচ্ছে এখানে ট্রাই করে দেখো 400 400 400 400, আলফা আসবে 0, মানে what gets reflected? Nothing, right? So it just goes in. This thing is like a very common question. Easy was. It's called a coupling medium. Coupling medium হচ্ছে a medium that bridges the gap between your transducer and the human body. Because যদি না থাকে এটা, তাহলে হয় না এটা. So you'll find that ultrasonography করার সময় ওই জেলটা অনেক দিতে হয়, because air এর জন্য most of the time the images are not clear, because there's always some air packets left behind, right? So yeah, that's the reason why we have this coupling medium. It's an artificial thing, but it has the same density as the human skin. That's why it works very well. Is to ensure that no is to ensure that no wave is reflected from the air to the skin boundary. So you're basically bridging the gap. সরি আবার বলো। রিফ্লেক্টেড রে গুলো মানে এখান থেকে যেগুলো রিফ্লেক্ট করে ব্যাক করতেছে নাকি ইনসিডেন্ট? হ্যাঁ, রিফ্লেক্ট করলে তো ব্যাক করবে, আর ব্যাক করার সময় কোনো প্রবলেম হবে না, বিকজ এটার তো কোনো ডেন্সিটি ডিফারেন্স নাই, সো জাস্ট যা আসতেছে ওইটাই চলে যাচ্ছে ভিতরে। ওকে, specific acoustic impedance, that's that. And alpha is this. Is there a way to relate Z to I? There's a way to relate alpha to I, but not Z to I. Okay, so let's move on. This is first part of our math. Bolshana, there's a question that you get with two parts. This is the first part. So what's the thing that we learned from the first part? The fraction that reflects. Also, এখান থেকে just মনে রাখো, the fraction that also goes in বের করা যায়. Like for this example, right? What fraction goes in? Right. So এটাও কিন্তু লাগবে. You will see right now can লাগবে. Sorry, clear so far? কি হচ্ছে? Okay, let's move to our next stage. Those who join later, just বলে রাখতেছি আজকের ক্লাসে হচ্ছে potentially, if your luck is in your favor, 15 marks পাবে এক্সামে। এই যা শিখতেছো এখান থেকে একটা ওরকম কোয়েশ্চেন আসতে পারে, like 10-12 marks এর combination of things, okay? Ultrasonography নিয়ে যদি কোয়েশ্চেন চায়, math is very important. So next হচ্ছে we'll learn about something called the absorption coefficient. And এটা হচ্ছে is applicable for every wave passing through the human body. So be it ultrasound, be it X-rays, whatever waves are passing through the body, this thing becomes a factor. What is it? So it is nothing but the information that if you have a part of your body, right, muscle tissue, whatever, as a wave travels through this part of the body, এই যে ওয়েভটা এন্টার করলো এখানে, and এটার হচ্ছে original intensity হচ্ছে I. The initial intensity here is I. As the wave travels through the body absorbs energy from it. And as a consequence, when the wave comes out from the other side, is it the same intensity or lower? Lower, because the body absorbed it, right? You need to know how much actually makes its way to the other side. So আমাদের যেটা এক্সামে করতে দিবে is they'll give you a thickness of a body part, let's say a tissue or a muscle or something, and that distance is x, thicknessটা। তোমার ইনসিডেন্ট হচ্ছে I naught, তোমাকে হচ্ছে বের করতে হবে what is the intensity that comes out from this structure. That's the question that you get, okay? So তোমাদের হচ্ছে এই জিনিসটা বের করতে হবে। Why is this important? This will help you figure out how far can your wave travel. Is at a point intensity komte absorb hote hote, what will it become? Zero. So there's a limit to how far they can travel, right? So how do we do this? It's a very basic equation. I equals to I naught e to the power minus mu x, and the mu is the absorption coefficient. It a different material, different values again. So this is called the absorption coefficient. And x key thickness, like what distance you travel. I naught হচ্ছে incident intensity of the wave that's entering, and I হচ্ছে the intensity that is attained at the end. Yeah. Okay, so I equals to I naught e to the power minus mu x. Any question? It's a very standard, straightforward equation, but the implication on it strong. I'm going to show you what it does. Yeah, I is what passes out. Our affect our body. বডিতে absorb হয়। হ্যাঁ, হ্যাঁ, কম হয়ে যায়। So your question is like, does it impact the outcome of the ultrasonography, this process? Yeah, it does. So the computer or the software that does it reverses the reduction and then gives you the value. So কমে যাচ্ছে না, ওটাকে amplify করে দেখায় so that you can see the information properly. কারণ every time the wave travels through a body, it keeps decreasing, right? So যে reflection গুলো back করতে থাকে, ওগুলো কি হতে থাকে, decrease হয়ে যায়. But the ones that travel very far take what time to come back? Longer time. So the computer can process that has traveled very far. Intensity only কমে গেছে because of absorption, right? So it will reverse করে দেয়. So it reverses it back to its normal value. And so you can compare them all at the same intensity. Okay, so একটা question করি তাহলে তোমাদের idea হবে যে কি হচ্ছে এখানে, but so far have you understood this, the reflection part, and have you understood this, the absorption part? So what kind of a question can you get in your exam? Let's see. Okay, try this. So আমি একটু দেখাই questionটা আগে. It says that ultrasound wave enters with intensity I naught and travels through the layers as shown. So it travels through muscle, then bone, and then muscle, and then back out again. Find the intensity that it makes its way out of these structures. So এটা যদি I naught হয়, কতটুকু এখান থেকে বের হচ্ছে ওটা বের করো। কারণ এখানে কি multiple place absorption হচ্ছে না? But ignore reflections in the inner layer. Now the problem is, a question যদি exam আসছে, it's 3 marks on its own, right? But sometimes they'll do this. They'll ask you to find the actual intensity that comes off from the other side. তখন what do you need to include in your answer? Yeah, so যে এখানে যখন বাড়ি খাচ্ছে প্রত্যেকটা জায়গায় কিছু রিফ্লেক্ট করে চলে যাচ্ছে না, ওগুলোকে ইনক্লুড করে ম্যাথটা করতে হবে, and I think you can understand it's going to be very elaborate at math. That's that 8-mark question. Okay, it's just time consuming, but in terms of what you need to do is the same thing. বারবার z বের করবা, alpha বের করবা, তারপর intensity apply করবা. Right now I just want you to do this much, where you have an intensity of I naught and এখানে multiple layer দিয়ে যাচ্ছে, absorb হয়ে যাচ্ছে না, কতটুক বের হয় এখানে ওটা বের করো. Assume that the reflections are very negligible. আচ্ছা, so দেখো কতটুক হয় এখানে. And এখানে হচ্ছে there's this just আগে heads up দিয়ে রাখি, একটা math identity যদি use করো, like math এর একটা idea, then you can actually solve this question in one step. And marks scheme they do that. But then I try to do that in class and I see that students don't understand that math idea. So তার জন্য হচ্ছে যদি কেউ এটাকে simplify করতে পারো using concept of math, right? করো. There is no problem in it, okay? I'll show you that way. But right now, যেভাবে পারো answer করো. Find me the intensity at the end of the whole process. This one, which one?
So the question that might come
Oh, আচ্ছা, the one that comes in the exam. এটা আসে by the way, but ওরা যেটা করবে যে এখানে ধরো হচ্ছে z দিয়ে দিল, এখানে z দিয়ে দিল, তাহলে যে ইন্টেন্সিটিটা এন্টার করতেছে ওটা কি পুরোটা এন্টার করবে নাকি কিছু রিফ্লেক্ট হয়ে যাবে? হ্যাঁ, রিফ্লেক্ট হওয়ার পরে যেটা বাকি থাকে ওটা এন্টার করবে না, ওইটা করে করে ম্যাথ করতে হবে. 6.85 মানে তোমার কি 0.0685 আসছে? 0.0685. হ্যাঁ, ঠিক আছে. How do you do it? কেমনে করছো? প্রত্যেকটার সাথে মাল্টিপ্লাই করে করে করছো? Or distance কত নিছো? আচ্ছা, multiple step করে আগাইছো? What did you do?
I got the segments.
How did you do it?
I multiply each layer.
Oh, acha, so first you found I, and then into e to the power this, and then order over e to the power that. Acha, okay. Can you see that?
And but divide it by another element.
Yes. Zero point 0.0685 I naught. Yeah. Ashe. By the way, তোমার মিউতে যে ইউনিটটা দেওয়া আর ডিস্টেন্সের ইউনিটটা সেম রাখতে হয়। এখানে মিউ কি সেন্টিমিটারে দেওয়া না, সো ইউ কিপ ইউর ডিস্টেন্স ইন সেন্টিমিটার। অনেক সময় মিউ দেওয়া থাকে মিটারে আর ডিস্টেন্স থাকে সেন্টিমিটারে, তখন কনভার্ট করে দুইটাকে সেম করে নিতে হয়। ইটস নট ইম্পর্টেন্ট যে সেন্টিমিটার না মিটার, ইটস জাস্ট দে হ্যাভ টু বি সেম। Okay, so Koreata, you have your wave entering here, I naught, and it then travels to this part of the body, right? How much intensity reduction takes place in this part of the body? So how do we do this? I equals to I naught times e to the power minus mu koto 2, 3 and x koto 4. So এটা use করে তুমি যেটা পাবা এখানে will tell you how much is the information at that location, এই জায়গাটাতে intensity কত আসে এটা 0.3985 I naught, which means that tomorrow intensity at this place is 0.3985 of what? The original value. Then what do we do? Yeah, এখন আমরা B তে করব। So at B তে কি হবে? B তে again I'll use the formula I equals to I naught e to the power minus mu x. কিন্তু this time the I naught is not I naught. It is how much? Yeah, exactly. So it's going to be 0.3985 times again e to the power mu হচ্ছে for 0.14 and x হচ্ছে 6. So এটা করলে তুমি যে ইন্টেন্সিটিটা পাবা কোথায় পাচ্ছ? At that location, right? So কত আসে এটা? 2. আচ্ছা, I naught. So intensity এখানে কমে যাচ্ছে, which is natural because আরো absorption হচ্ছে এখানে 20 I naught. Clear? Now we want to find the one at the final location there. So আবার কিসের ভিতরে enter করতেছে? Muscle. So I'll again do this here. So at C, what should it be? I equals to, what's the I naught going to be this time? Yeah, 0.172 times e to the power minus mu হচ্ছে 0.23 times x is how much? 4. And এটা করলে হচ্ছে কত আসে finally? Right, I naught. And that's what comes out from the structure at the end. Bolo? In one step. And you're multiplying all of them. Acha, yeah, you get. So আমি একটা জিনিস দেখে এখানে কি শর্টকাটটা ইউজ করা হয়। So if you look at the mark scheme, they don't do this. আচ্ছা, ওরা কি করে? ওরা এটা করে, let's say সবাই স্ক্রিনে e to the power a into e to the power b into e to the power c. What is it going to be? A plus b plus, do you know this? এটাই হচ্ছে এখানে দেখো কি হচ্ছে, এই যে এইটার সাথে আমি এইটা মাল্টিপ্লাই করতেছি, তারপর এই দুটার সাথে আমি এটা মাল্টিপ্লাই করতেছি। So wouldn't that mean that I is equal to I naught into e to the power কি হবে মাইনাস ভিতরে যেগুলো থাকবে, so 0.23 into 4 plus 0.14 into 6 plus 0.23 into 4. For the sake of it, you have to check করে দেখবো কি same answer আসে নাকি। Right? So this is the step you'll find in your mark scheme, okay? It's easy. It makes your, so if you have 200 layers, right? It doesn't matter. Just add করতে থাকবা. If you do it this way, 200 layers শুনলে মনে হবে there's a lot to do, right? Because you have to do this 200 different times. So anyways, এখানে যেটা আসছে that's the answer 0.069, let's say. Yeah, so here's the thing. I'll give you a question on that right now. So do you remember that we ignored the reflections here? The reflections do have a factor, right? So it used for economic math because I didn't want the reflection to be your barrier in this question. I just wanted to see if you understand the absorption part. So this math entirely, the intensity change is due to what? Absorption. But don't we know that boundary that there's also reflection? Reality konta, absorption or reflection, or absorption and reflection? Both, right? So it is the math that you'll get. So it is clear, then I can show you that. Okay, so let's do one there. Shubida ki oi question ta dile, they won't give you many layers because it becomes awfully too long as a question, right? So what jeta dibe is something like this. So try and answer this. Eta hocche value gulo dicchi. This is why not? Find this for me. এই যে এটা বের করো। The values, অনেকগুলো value দিব তোমাদেরকে এখন, so to carefully দেখো. So you need to find this I for me. What is this intensity here? এখানে কি হচ্ছে? Absorption and reflection. Okay, so you have your muscle layer here and you have your muscle layer there. Our মাঝখানে you have your bone layer and thickness distance of দিয়ে দিচ্ছি. The thickness of this layer that you see here is 4 centimeters. And mu for muscle, mu for bone, সব লাগতে পারে নাও লাগতে পারে, is 0.14 per centimeter, 0.23 per centimeter, and Z for muscle and Z for bone. Actual value of data. Bonetta হচ্ছে 7.0 into 10 to the power 6 kg per meter square per second, and muscle হচ্ছে 1.68. হ্যাঁ বলো। Yes. So আমাকে বের করে বলো what is the intensity that comes out from the other side? এই নিচে যে ওয়েভটা বের হচ্ছে এটা ইন্টেন্সিটি কত, এটা বের করো। I hope এটা এক্সামে আসে, because যদি actually পারো, it's not that complicated and you get quite a lot of marks for it, combined like 7-8 marks. That tells you how much is reflected. So using that information, you can find out how much actually makes through. Excuse me, 0.309 I naught. Point 356. By the way, the alpha for muscle to bone and the alpha for bone to muscle, is it same or different? Same. কারণ Z1 minus Z2 আরটা হচ্ছে Z2 minus Z1 ম্যাথ যদি করো same value দেয়। So you know the boundary coefficient is same, muscle to bone, bone to muscle. ওটা আগে আর সেভ করছো, তুমি কি মাসলের ভিতর দেওয়া গেছো? বাট আমরা লেন্থ জানি না, বলো। 0.71. 0.71. So 0.6. Okay, করি আমরা। Are you ready? Acha, so I want to hear an answer from everyone because you have to try this, otherwise শিখা হবে না। 0.223. Okay, that's one. 0.0806. 0.3356. আর কেউ শেয়ার করতে চাও? 346. 6243. 223. 0.223. 0.61. Okay. Arkeo? 356. Okay. Right, let's start. কেমনে করতে হয়? So first, এই boundary-তে কাজ করব আমরা, and we will try to figure out what is happening at that location. Okay. So এখানে যে ওয়েভটা আসতেছে I naught, will all of it enter? No, right? So there'll be two things going on here. একটা কি হবে এখানে? Reflection. আর আরেকটা কি করবে? Refraction, which will go in here, right? Right. Could you find the I here? Sorry, alpha. So এটাকে A বলি আমরা। At A, alpha কত? So কেমনে বের করব? এই values গুলো use করে। This one minus that one divided by this one plus that one. Right, alpha কত আসে? 0.376 I naught. আসছে সবার এটা? Just confirm করে নি, যাদের আসে নাই দেখো কি problem. Sorry? It's still the same answer. Why same answer? Because it's a boundary thing. So it doesn't matter if it's A to B or B to A. It's the boundary that matters, right? So it আসছে না 0.376 সবার? Clear? Okay. But what is that though? That is 0.376 I naught, the amount that is reflected. But we need which one? The one that enters, right? So এটা কেমনে বের করব? So that's going to be I naught minus 0.376 I naught. How much is the one that enters and goes inside? 0.624 I naught. Do you understand? এটা কি clear তোমাদের কি হচ্ছে? Okay, fine. Then আমরা যেটা করব, we'll do the exact same thing at that location. Is that the right thing or do I need to do something else? Yes, very good. So এটা করা যাবে না। এখানে এখন আমাদের next যেটা করতে হবে, in the bone what happens? So in the bone, what does the wave undergo? the wave experiences key absorption, right? So তোমরা কি absorption ভুলে গেছো? শুনে তো মনে হচ্ছে you didn't take that into account. Absorption হবে না মনের ভিতরে? So absorption হয়ে কতটুকু বাকি থাকে কেমনে বের করব? I equals to I naught e to the power minus mu x. What is my I naught that enters this bone here at the top? 0.624 into e to the power minus, what's the mu for the bone? 0.14 into what distance does it travel through the bone? 4. And once you do this, you will find the intensity that reaches where? At the bottom, correct. So কত আসে এটা? 0.356 I naught. এটা বের করছো তোমরা? এরপরে যে হবে ওটা করোনি? Okay, so this is the wave that reaches which location? The bottom there. But এখান থেকে এখানে বের হওয়ার সময় will all of it move out, or will there again be reflection? There will again be 2 minutes, okay? There'll be again reflection here, right? So how do you find this one? এটা কেমনে বের করবা? Yeah, so ওই যে আমরা একটু আগে যেটা করলাম ওইটা আবার করি। এবার আমাদের already alpha যেহেতু জানা, we don't need to do this. So কেমনে করব? Alpha is equal to IR divided by I naught or I incident, right? What is alpha? এই যে এই আলফাটা কত আসছিল? না 0.376. ওইটাই না আলফা? না আলফা কত ছিল? Just right, so 0.376, right, equals to what's my reflected, এটা বের করতে যাচ্ছি, and what's my incident is a 0.356 I naught. কি একটু বের করে বলবো আমাকে যে রিফ্লেক্টেড কত হচ্ছে এখানে? মানে যে 0.376 into 0.356 বেড়ে গেছে। (0.1339 I naught. এটা কি কেউ বলতে পারবে কোন ভ্যালুটা এখানে in the diagram? Very good, right? The one that's actually going and reflected out here. So that is 0.1339. But that's not the answer. তোমরা কোথায় যাচ্ছ? আগে answer করে যাও। So of the one that came in, right, at the bottom, এই জায়গাটা কতটুকু reach করছিল? আমরা ম্যাথ করছিলাম। কত reach করছিল? 0.356. Of that, this is reflected. So therefore, finally, the one that passes through wave leaving should be how much? Yes, 0.356 I naught minus 0.1339 I naught. কত দেয়? 0.222. There you go. Now, whichever like sequence of events you use to get to the answer, it's up to you, but that's the answer. বুঝছো? The 1 minus factor. Yeah, you could have done that. So you can notice 0.376 now multiply করে, you could have multiplied 0.624. Squared it on the first step. Yes, because it's a multiplicative thing. You can do it before and after. Correct. This particular question is 5 marks. Today? No.
They ask, like, state the reason why the gravitational potential energy of the satellite increases or decreases.
Potential. Let me see. The change in mass is into an exponential radius.
It goes to a bigger radius, right?
It goes to a bigger radius. That's what I'm looking for.
So that 94 to like 150. So it goes to a bigger radius, right? The period of orbit changes.
Yeah, so if it goes to a bigger radius, whether the gravitational potential energy of the satellite increases or decreases.
Shouldn't it decrease? Because like if the radius.
No, if you fall, it increases. If you go up, it decreases. Sorry, let's say a ball. If you release a ball, as it falling, right? What happens to the potential energy? Decreases. So if you raise it up, it increases. Okay, this equation shouldn't work. Did you try this equation? Yeah. So because there's a minus sign here, so your value is decreasing, but a negative value decrease means it's what?
It's all going in the.
Yeah, minus 15 and minus 20. Which one is bigger?
Minus 15.
Yeah. So that's your absolute value is actually decreasing, but there's a minus sign here, which means it's increasing.